Hello, this is the first of our Excel labs to be videotaped. And I just want to start with a disclaimer. And my disclaimer is, I'm not that wild about doing this. I think it's a worthwhile thing to do, which is why I'm doing it. But in fact, I'm not that comfortable with this medium. So most likely this is going to be a very imperfect video. So I apologize for that. But I think this is the best way for us to proceed here. So what you're looking at on my screen is a piece of the, well, it's actually a piece of your syllabus for part 2 of the project. This is for the confidence interval estimates for proportion and mean. So there is an introduction to the question of interest that you need to submit, and of course you're not going to submit my introduction because that would be plagiarism and that would be a bad thing, but you do need to fill in a few sentences here about what you collected data, what were the topics or questions of interest for your data collection, and how you went about doing it. Then there's also room here for the questions, so you need to submit those as well, so I know what your data was about. And here we want to provide the results to these questions. So that's where we're going to start with this. So the sheet that we're looking at in Excel is where we last left this project. So when we last looked at this project, you had your original data set, which was either 20 to 25 pieces of data in length, and we extended that using the random number generator to 100 pieces of data. So I'm assuming that you have this, and we will now start from here, and I want to fill out this table so that I can provide in my data set the proportion of males, proportion of females, proportion that texted while driving, proportion that didn't, and so on. So I want to be able to fill out this table, and then we'll work on the other pieces of what you need to submit. Okay, so to start this, I'm going to look at this bigger data set, and I'm going to put this data, I'm going to subset this data on another sheet. And by subsetting the data, what I mean is I'm going to break this data up. See, I have these two categorical variables, gender and text, and I'm going to break this up into males and females, and then texting and not texting. So that's where I'm going to start with this. So to do that, I'm going to first select the group that I'm interested in. So gender, for example. I think I coded this as 1 for female and 0 for males. And I'm going to apply a filter. And once you apply the filter, you can see you can select everybody, which is what the current selection is, or I can just select the females. So if I just select the females, then I get a subset of the original data set, and I'm going to copy and paste this onto the next page. So this is going to be for the females. And I'm going to grab this data and put it on the next page. So that's going to help me, because then I'll know just for females what all the questions of interest for this group. So for pay special, I just want the values. And so there they are. This is the female data, and some of them text while driving. In fact, none of them. See, it's interesting, all these the text is 1 for each of these entries, and the way I coded it, text equal to 1 means no, they don't text while driving. So what this tells me is in this data set, none of the females texted while driving. So it's 100% on that one. Okay, so I guess that's of interest. And now I want to look at I want to grab the male data. So I'll go back to the random, what's this? Oh, this is the data that I have. Okay, so I'm going to change the filter from 1 to 0, and now this is the males. So again, I'm going to copy and paste this onto the new sheet. So here I'm going to just paste the values. And so here's the male data, the males. Now, so in terms of which percentage was male and which percentage of males and females, well, actually, we can add up. I mean, I already know that it's going to be this number minus 2, so it must be 64, but let me just check that out. So what I'd like to know now is, what percentage. I want to fill in this table to present the results of this data set. So I'm going to fill in this table and be able to say what percentage of males, what percentage of females in my data set, and what percentage texted, what percentage didn't text, and so on. So in order to do that, I'm coming here with the females, and I'm just going to add up the number of females, even though I already know. I'm going to pretend I don't know. And to add these up, I'm going to use a sum function in Excel. So here I'm going to use equal to. Now sum came up right away, as that must have been a recently used function here. But if it didn't come up for you, you can go click on this f of x for insert function. And it came up here right away also because it had been used recently. That's the category here, most recently used. But if we went to all the functions that are stored internally here and clicked on OK, whoopsies, that's not what I wanted to do. Let's try that again. Again, this is an imperfect video. So this is equal to, and we'll click on f of x, and again we want all. But if you look in this list, I'm going to look for sum in the list. So you would have to do this if, if it hadn't come up, if you hadn't used it before. So there's all kinds of summations, but here's the sum that we want. So it's just a plain summation, and you just provide, the numbers in a range of cells. So I'll say sum is what I want. Now, I can use this syntax. It's been provided for me, but just to make sure, if I click on the red arrow and I select the cells I want, I'm summing on, so I can select them. Whoopsies, I want to go to 66. So I think that's what it had there before. And click back on the red arrow. It will substitute the syntax that you need, in that space. And it does go column, row, colon, column, row. So anyway, that's what it is. And there's 64, which we knew that because it was 66 minus 2. But anyway, what does that tell me? 64, there's 100 pieces of data, so 64 of them are females. So here I can go to the table and say this was 64%. So it was 64% female, so then right away you know the percentage of males, because 100 from minus 64% is 36. So this must be 36%. So I have 36% male and 64% female. So the vast majority of my respondents were female. Okay, and now we'll play the same game with texting while driving. So I again have to go back to this original data set. I have this filter. Now I can keep the filter here. It doesn't matter. I'm going to go to select everything. So the filter's there. But if we wanted to get rid of the filter, we could click on this and then just click back on filter, and it would make it go away. Now here for text, I'm not sure if I can just click this and go to filter. Okay, it put a filter on all the variables, which is fine. I certainly don't need it on all the variables, but I did want a filter on text. So here you can see gender, everybody's selected, both the males and the females. But here with text, if I select, this is, the one here is coded as does not text while driving. So this is that group. Okay, so by sheet 2, instead of having males and females now, I want, let's see, this first group is does not text. Not text while driving. Okay, so that's going to be the first group that I pull in. And so that's the group that was coded with a 1. So now I can select these people. And copy and paste them here. And there they are. And then this will be the group that texts while driving. Okay, so yeah, and you can see, you know, not text while driving, all the text variable, they're all coded with a 1. And go back to the random data here. And if I want the other group, I want the zeros. So here's the group that have texted while driving. So it's this group here. And so now I have them. And I didn't even mention about pasting special. I just pasted them in the default way. Okay, so there it is. So now I want to know what percentage texted while driving. So texting while driving, well, it's actually easier since I coded not text while driving as the 1. I'm going to add these up. So underneath these, I'm going to add this up. So again, this is going to be equal to. You need an equal to anytime you want to use an Excel function. An equal to has to precede it. So I have equal to, and sum is already here, so I just did that once, so I'll just select it there. And I'll click on the red arrow because I want to make sure I'm selecting what I want to select. So I'm selecting these. I'm counting. Really, I'm just counting the number of respondents who said they have texted while driving. So I have 68. So since this is already out of 100, then this must be texted while driving. No is 68%. If this was not out of 100, then you'd have to do a ratio, you know, this number over the total and multiply by 100 in order to get the percentage. But since it's already out of 100, you know, percentage is out, you know, K% is K over 100. All right, so then what do we have here? We must have, what do we have here? We have 32%. So this is 32%. So 32% of my respondents have texted while driving, but 68% of my respondents have never texted while driving. Okay, and so, well, let's see, I have our questions are, so here I could actually say our results are. So let me switch this to results. Results, or I can't say questions and results, let me fix that. Questions and results. Or I could say summary instead of results, maybe that's a better word. Okay, now estimate the average number of texts you send each day. So that variable here is called average, and it's the average number of texts sent typically per day. Okay, so I would go to the original data for that. So I don't need a filter on that. So I can undo this filter. And so no one's filtered now. No filters, no filters. And then these filters, these are going to have there's no number which is represented twice, so every number is its own filter, so we could just, let's just get rid of that. All right, I got rid of all of them. I don't really need them anyway, but I could have selected that one and then selected, it's a toggle, filter's a toggle, and turned it off. Okay, now it turns out to generate the data, I've already done this. So for the average number of texts in a day, we did the descriptive statistics for that, and that's here on this original sheet. We had done that in class. So the mean number of texts per day is here. Now this was an integer value, so I'm going to round, so I'll give one addition. Since I have original data, the rounding rule would say, or would indicate that since the original data was to the nearest one, I can add one additional digit. So this number would be represented as 20.5. So the average number of texts per day is 20.5. So what does that mean? Let me put a little interpretive statement. So on average, 20.5 text messages. Okay, so I have that. So how often do you text during a typical class? So this variable, because we generate, I mean for me, and you may have a variable that's like this also. So this variable, oh, where's the questions? Oh, the questions are here. This variable is, what is this? This is, the level of measurement for this is not a ratio level of measurement. It's right. I mean, the ratio level of measurement, if you remember from Stat 1, ratios are meaningful. There's a true zero. We don't have that here. These are sort of like categories. This is maybe a notch above categorical. This is actually categorical, even though I'm treating it as something other than categorical, because these are categories, but they have numbers associated with them. So anyway, it's a little problematic here, because this scale goes from 0 to 6, and they're whole numbers. But if you look at the data that was generated, since these were generated according to a normal distribution, with the mean that was the original mean and the standard deviation that was in the original data, some of these values are negative, and that has no meaning for the original variable. So this is intrinsically problematic. And if I took the absolute value of each of these, then I'm going to change the normality of the data. So what to do? So I think I'm just going to leave the mean the way it is, and interpret the mean as is. And I'm going to currently ignore the fact that some of the some of these numbers are negative. If you have a variable where you have a similar situation and you want to talk about how to interpret it or what to do, feel free to talk to me about it, and we'll discuss what might make sense. So I am kind of ignoring a problem here, which is negative values have no meaning here. Okay, problem. Anyway, I do have a mean, which is a positive mean, so that's nice. And this mean was from the original data. It was from the 20 data values that I had in the original data set. So the mean here, if we give one additional digit, is 1.5. So I can put that as part of my results here. So 1.5, or well, 1.15. So if I rounded to the nearest tenth, that'd be 1.2. So 1.2 average. So I should say average equal to 1.2. And the same thing here. This should have been average is equal to 20.5. Okay, so what does that mean? So I'm going to interpret that. So on average, students. Oh no, actually that's not the number of text messages sent. What does that actually mean? It means it's 1.2. So rarely. So I have to interpret this in the context of this scale, and 1.2 is closer to 1. So I would interpret this as students rarely text during a typical class. So that's how I'm going to interpret this. So on average, students rarely. In a typical class. Okay, so there's my interpretive statement. Okay, so now I want some pie and bar charts and the sample proportion. Okay, so you know what? I'm going to break that up into another video so that these videos are not too long. So I'm going to